As a Clown here for Clown Maths. Today we're going to look at the Advanced Higher Maths paper for 2022, non-calculator to start with. Let's get straight into it with question 1. So question 1 says, given that y equals 1 minus 3x over x squared plus 4, find dy by dx and simplify your answer. And then part B of that question, given that f of x is cosec 5x, find f dash x. So the first question is just a quotient rule question, and the second question is just a trigonometric function, which we can use to start the exam paper. So 1a, the y by the x is 1 minus 3x over x squared plus 4. So I'm going to let u of x equal 1 minus 3x. So that means u dash of x is minus 3. And I've got to let v of x equal x squared plus 4, which means v dash of x is 2x. And if you remember our quotient rule for our function, u of x over v of x is u dash v minus v u dash all over v squared. V's all being a function of x. So substituting everything we've got in, that gives us minus 3 x squared plus 4 minus 2x 1 minus 3x all over x squared plus 4 all squared. So that equals minus 3x squared minus 12 minus 2x plus 6x squared over x squared plus 4 squared. That gives us 3x squared minus 2x minus 12 over x squared plus 4 all squared. And we're done. Okay, question B says, given f of x is cosec 5x, find f dash x. Well, if we go to the front of the exam paper, it will tell us that standard derivative, which I've copied here, of cosec x is minus cosec x cot x. So we know f of x, so we can work out f dash x straight away. So that gives us minus 5 cosec 5x cot 5x. And we're done there. Question 2, use Gaussian elimination to solve the following systems of equations. So we can set up an augmented matrix. We've got 1, minus 2, 1 and 4. 2, 1, minus 3 and 3. 1, minus 7, 4, minus 4 and 9. Remember, the goal with the augmented matrix is to give zeros in these positions here. So the first thing I'm going to do is do row 3. That's going to be row 3 minus row 1. And simultaneously, this row is going to become row 2 minus 2 row 1. So being careful with our numbers, we've got 1 minus 2, 1, 4. 2 minus 2 is 0. 1 plus 4 is 5. Minus 3 minus 2 is minus 5. 3 take away 8 is also minus 5. And then row 3 minus row 1, that gives me 0. Minus 7 add 2 is minus 5. Minus 4 add 1. Take away 1 is minus 5. And 9 take away 4 is 5. So remember what we've got, we want to try and get a 0 in this position here now. So if we just add these together, that will give us that. So that becomes row 3 plus row 2. So we've got 1 minus 2, 1 and 4. 0, 5, minus 5 and minus 5. 0, 0, minus 10 and 0 again. So we should be able to see clearly now that that means that minus 10z equals 0, which implies that z equals 0. Then we've got 5y minus 5z equals minus 5. So we've got 5y equals minus 5. So y is minus 1. And the last equation we've got is x minus 2y plus z equals 4. So that's x plus 2 plus 0 equals 4. So x must equal 2. So our system of equations is solved. X equals 2, y equals minus 1, and z equals 0. Question 3, given that z1 is 5 plus 3i, z2 is 6 plus 2i, express z1 times the complex conjugate of z2 in the form a plus ib, where a and b are real numbers. So we've got the complex conjugate of z2 is just 6 minus 2i. So z1 times z2 bar is just going to be 5 plus 3i. 6 minus 2i, expanding the bracket, so we get 30 minus 10i plus 18i minus 6i squared. But remember, I squared equals minus 1. So z1, z2 bar equals 30 plus 8i plus 6. So that gives us a final answer of 36 plus 8i. So a in this case is 36 and b is 8. Question 4, use implicit differentiation to find an expression for dy by dx. So we've got for 4a, y cubed plus 4y is 2xy plus 1. Now this bit here is a product, so for the product rule we're going to say that u is 2x, v is y, so u dash is 2, but v dash is just going to be dy by dx. And remember that's going to differentiate that, we've got uv dash plus v u dash. So going back to the left hand side, we've got 3y squared, but dy by dx, plus 4 dy by dx. And then on the left hand side, 2x for u, v dash is dy by dx, plus y for v, and u dash is 2. And differentiate 1, you get nothing. So that gives us 3y squared dy by dx plus 4 dy by dx minus 2x dy by dx equals 2y. Dy by dx out. 3y squared minus 2x plus 4 equals 2y. And therefore, dy by dx is simply 2y over 3y squared minus 2x plus 4. Part B says find the gradient with tangent to the curve from y equals minus 1. So we've got a y value, but we're going to need an x value as well. So remind you of the original equation, which I'll just paste in. That was our original equation. So at y equal to minus 1, we have minus 1 cubed plus 4 times minus 1 equals 2x times minus 1 plus 1. That gives us minus 1 take away 4 equals minus 2x plus 1. Minus 5 take away 1 is minus 2x. So x equals 3. Minus 6 divided by minus 2 is 3. So we've got x equals to 3 and y equal to minus 1. So using the y by dx now. So there's our dy by dx. Y equals minus 1, x equals to 3. Dy by dx equals 2 times minus 1 over 3 times minus 1 squared minus 2 times 3 plus 4. That's minus 2 over 3. Take away 6 plus 4. So dy by dx. 3 take away 6 is minus 3, plus 4 is 1. So dy by dx equals minus 2. So the gradient of the tangent at y equals minus 1 is minus 2. Okay, so the curve has no stationary points. So we get stationary points when dy by dx equals 0. Stationary points when dy by dx equals 0. So remember this was our dy by dx. So we're just going to say that. And we're going to make that equal to 0 and see what happens. So we can easily solve this. That implies if the y by dx equals 0, then 2y equals 0, which would imply that y equals 0. So at y equal to 0, we would get 0 plus 4 times 0 equals 2x times 0 plus 1, which would give you a 0 on the left-hand side and a 1 on the right-hand side. That's a contradiction. There's no intersection with the line y equal to 0. That implies that there must be no stationary points. Question 5. Find the simplified Maclaurin expansion for e to the minus 4x up to including the term in x cubed, and then hence find the first 4 terms of the Maclaurin expansion of this function. Now, if you've memorised the standard power series for e to the x, then you can just jump ahead and jump straight in. Let's assume you haven't memorised that or forgotten it. You can still use the Maclaurin expansion, which given at the start of the exam paper is this. So clearly from this expansion, we need to find a few things. We need to find f dash 0, f second derivative, third derivative, up to here. So let's just do our derivatives. So we know that for part A, f of x is equal to e to the minus 4x. So f of 0 is equal to 1. F dash x is minus 4 e to the minus 4x. So f dash 0 is minus 4. Second derivative is going to be 16 e to the minus 4x. So our second derivative at 0 is just 16. And third derivative is how far we need to go. Minus 64 e to the minus 4x. I've forgotten x here. So our third derivative at 0 is just minus 64. Substitute into our Maclaurin expansion. So f of x equals f of 0 plus minus 4x plus 16x squared over 2 factorial plus minus 64x cubed over 3 factorial. We can tidy that up. 1 minus 4x. 16 divided by 2 is 8, so plus 8x squared. 3 2s are 6, so you get 64 over 6, which is 32 over 3. And we've done part A. Part B, hence find the first 4 terms of the Maclaurin expansion of 3 plus 2x over e to the 4x. We've got 3 plus 2x over e to the 4x. Well, that's the same as 3 plus 2x times e to the minus 4x. But we already know what e to the minus 4x is. It is this. So that's the same as doing 3 plus 2x times 1 minus 4x plus 8x squared minus 32 over 3x cubed. up to the x cubed terms. So we've got 3 minus 12x plus 24x squared minus 32x cubed plus 2x minus 8x squared plus 16x cubed plus minus 64 over 3 x to the 4. And this term is not required, remember, because we only want it up to x cubed. So that equals up to the term in x cubed. We've got 3 minus 12 plus 2 is minus 10x. 24x squared minus 8x squared is plus 16x squared. Minus 32x cubed plus 16x cubed is minus 16x cubed. And we don't need anything else. So we're done. There's our final answer. Question 6. Consider the statement for all odd numbers n squared plus 4 is prime. Find a counterexample to show that the statement is false. Nice and simple, this one. We just need to find the number odd. So we just try it in our heads. 1 squared plus 4 is 5. 3 squared is 9 plus 4 is 13. 5 squared is 25 plus 4 is 29. 7 squared is 49 plus 4 is 53. 9 squared is 81 plus 4 is 85. Oh, that's in the 5 times table, so it's not prime, so let's just write that out. So for n equal to 9, 9 squared plus 4 equals 85, which is not prime, as you can find the number 5 times 7 equals 85. So we've proved it by counterexample. Okay, part B. Prove directly that the difference between the cubes of any two consecutive integers is not divisible by 3. So let's take an integer, any one we want. Let's call it n. Then the next consecutive integer is clearly n plus 1. N plus 1 cubed minus n cubed. Expanding n plus 1 cubed, we get n cubed plus 3n squared plus 3n plus 1 minus n cubed. We've used Pascal's triangle for that. That implies we've got n cubed minus n cubed is nothing. We've got 3n squared plus 3n plus 1. Should be able to see then there that we've got 3 bracket n squared plus n plus 1. So let's just call that m. That's 3 times m. So 3m is divisible by 3. And therefore, obviously, 3m plus 1 is not divisible by 3. As there is a remainder of 1. Always a remainder of 1. The difference between the cubes of two consecutive integers is never divisible by 3. Done. Question 7. Use the substitution u equals y squared plus 1 or otherwise to find the exact value of the integral between 0 and 5 of 4y over the square root of y squared plus 1. So if u equals y squared plus 1, then du by dy must equal 2y. So that implies that du equals 2y dy. So 2 du must be 4y dy. So make our limits for the integral. So remember, at y equal to 0, u equals 1, and at y equal to 5, u equals 5 squared plus 1, which is 26. The integral between 1 and 26 of 2 du over the square root of u. That's the integral between 1 and 26 of 2u to the minus a half du. So add 1 to the power and divide by the new power, u to the half. 2 divided by a half is 4. We can put our limits in. So we've got 4 times root 26 minus 4 times root 1, which is equal to 4 root 26, and root 1 is 1, so minus 4. Okay, 7b, student engineers are using a 3D printer to make a model, and it says, relative to a suitable set of axes, the cross-section is symmetrical about the y-axis and was represented in the first quadrant by the equation we just started off with, between 0 and 5 on the y-axis. State the area of the cross-section. We've just worked out that the definite integral between 0 and 5 and the y-axis is this. So for part B, we've got this picture, symmetrical about the y-axis, so on the other side it goes along and does the same thing. So you've just got another one of these and another one of these. So it's going to be 2 times 4 root 26 minus 4, 8 root 26 minus 8 units squared, because it's area. Question C says express y squared over y squared plus 1 in the form a plus b y squared plus 1, where a and b are real numbers. If it says the curve is rotated through 2 pi radians by the y-axis, find the volume. So we've got y squared divided by y squared plus 1. So that's y squared, no y, and no number. The y squared goes into y squared 1 time. 1 times y squared plus 1. 1 times 1, take away. We get nothing plus nothing minus 1. And therefore, a equals 1, b equals minus 1. We've got 1 minus 1 over y squared plus 1. So the curve x equals 4y over the square root of y squared plus 1 between 0 and 5 will be rotated through 2 pi radians about the y-axis to make the model. Find the volume of the model. So just a reminder, this is testing if you know that the volume equals pi times the integral of x squared dy. So let's work out our x squared. X squared just equals 4y squared is 16y squared over y squared plus 1. So our volume is equal to pi times the integral between 0 and 5 of 16y squared plus y squared plus 1 dy. The volume is 16 pi, the integral is 0 and 5 y squared over y squared plus 1 dy. That's 16 pi, the integral between 0 and 5 of 1 minus 1 over y squared plus 1, the y. So we can now directly integrate it. We've got 16 pi, 1 becomes y. And if you look at the start of the exam paper, that's the inverse tan. So it's the inverse tan of y. Between 0 and 5. So substituting 5 in, we get 16 pi 5 minus inverse tan of 5. Take away 0, the inverse tan is 0. So that gives us 16 pi 5 minus inverse tan of 5. 5 16s is 80, so we get 80 pi minus 16 pi to the inverse tan of 5 units cubed because it's volume. And we're done. This has been Claire Maths. Today we went through the Advanced Higher 2022 exam paper 1. Take care, stay safe and good luck with the rest of your exams.